5.2 Trigonometric Functions. We're really getting into trigonometry now, study of triangles. It says, let xy be a point other than the origin on the terminal side of an angle theta in standard position. So they're talking about like this point right here. Okay? The distance from the point to the origin is given by this formula. Now, if you really get into it and dig deep and think about it, okay, this is basically Pythagorean's theorem. It's the point xy has formed this triangle with the origin, and that side r happens to be the hypotenuse of that right triangle. Okay. Now, it might be good for you to understand how that triangle was formed and what r is and stuff. So imagine this initial side, and let's start this point over here. The angle, remember, was formed by rotating that terminal side around like so. So if you did the same thing with this point, the point just rotates all the way around. Think about if it rotates all the way around 360 degrees. Okay. Notice if you just took that point and rotated it all the way around, it makes a circle. Okay. So you might have questioned why in the world they used the letter R, but what is the R in reference to that circle? That's the radius of that circle. Okay, so the reason they use the letter R is because it just so happens to be the radius of that circle. Now that circle didn't exist in the original picture, but we're trying to turn this into a triangle, and that's what trigonometry is about, study of triangles. We're going to be looking at how that angle compares to the sides. All right, so there are 6 trig functions, and I already have the first 3 written down, so while you're writing, I'm going to write the other 3. There are actually 6. And so we start with those. I call these the big 3. Sine theta, cosine theta, and tangent theta. Those are the big 3. Those are the ones you see probably most often. Theta is the angle. It's a Greek letter. Get comfortable with Greek, because normally they'll use a Greek letter for an angle, but theta is the most common one. Other than sine, cosine, and tangent, we have cosecant theta equals r over y. We have secant theta equals r over x. And we have cotangent theta equals x over y. Now, you might notice that 4 out of the 6 trig functions have that extra little statement that says something cannot equal to 0. It's the denominator. You never want your denominator to equal 0. And so then that begs the question, well, why didn't I put it for the other 2? You can answer that question if you remember what R stood for. Okay? R stands for what? The radius of that circle. And will the radius of a circle ever equal 0? Not if it's a circle, because we learned in the last chapter that if you had a radius of 0, that's not a circle, that's a point, right? So as long as we're talking about a circle, we're going to have a non-zero radius. So we don't need that extra statement for the first 2 trig functions. All right, now, you probably want to have these 6 things memorized, okay? And it shouldn't be as hard as maybe you think, okay? You can go back in time and remember SOHCAHTOA. Sometimes I think that helps. But at the end of the day, what we're trying to do is establish relationships between the angle and the sides of the triangle, okay? So, in general, you've got a triangle that looks something like this, okay? And if you went back to geometry class and talked about sine was opposite over hypotenuse, if you look at the opposite side over the hypotenuse, that's giving you y over r, which is exactly what we have for the sine ratio. Okay, the sine ratio is y over r. That's the same thing as opposite over hypotenuse. So we're basically doing SOHCAHTOA, kind of, sort of. Okay, if I look at cosine, back in the day in geometry class, we said that was adjacent over hypotenuse. That's x over r. All right, so really, when I look at sine, cosine, tangent, cosecant, secant, cotangent, all that is just giving a name for which two sides make up my fraction. Okay, so why is it secant? Well, secant is this specific ratio. Why is it tangent? Well, tangent is this specific ratio. So those 6 things are just the names of this over this. Okay, there are 6 different possible ways. If I said, okay, take this triangle and I want you to make as many different fractions as you can. So you pick, you could say y over x or x over y, or you could say r over x, or you could say x over r, or you could say, what else is there? Y over r or r over y. There's only 6 different ways that you can pick too. Okay, that's a combinations problem. But there's 6 different ways, there's 6 different fractions, and that's why there's 6 different trig functions. Example 1 says the terminal side of angle theta in standard position passes through the point 8, 15. Find the values of cosine theta and tangent theta. So my default is that I like to draw a picture of this, but I almost think that makes it more complicated. So I'm going to do it without drawing a picture. I think you'll understand it better, and then I'll come back and draw the picture after that. Okay, they give me an x and a y number. I know x is 8, I know y is 15. It's pretty easy to use that formula then, because I've got r equals square root of x squared plus y squared. I can see square root of 8 squared plus 15 squared. 8 squared is 64, and 15 squared is 225. So when I add those together, I know that's 289. Use a calculator if you need to. I've done this problem before. That's why I know. Okay. So r equals the square root of 289, which is 17. R equals 17. And we have everything that we need to know because we're just looking at a ratio of 2 sides. Which specific ratio? Well, we use this one. Cosine theta is the ratio x over r. That's the 2 sides that we want, the 2 sides of that triangle. So what's the x number? 8, and what's the r number? 17, so that's it. Cosine theta equals 8 over 17. If you look at tangent theta, we know tangent theta is the ratio y over x. So the y number we see is 15 and the x number is 8. That's all we needed. Cosine theta is 8 over 17. Tangent theta equals 15 over 8. Now, if you imagine the picture, okay, think about this picture. They're saying go over 8 and go up 15, and there's a dot there. This angle that we have goes through that point. All right. It just so happens that that defines a right triangle. And if you look at that right triangle, this side is 8 and this side is 15. And if you did Pythagorean's theorem, you're going to find the hypotenuse is 17. So all we are doing for trig here is we're looking at a ratio of 2 sides. Okay? We're looking for a ratio of 2 sides. Which 2 sides? Well, it depends on which trig function. Okay, the cosine ratio defines the x side over the r side. If I was looking at the tangent ratio, it would be the y side over the x side. Okay, so if you think about it, there are only 6 trig ratios. Really, all I'm doing is I'm picking 2 sides at a time. This is a probability problem or a combinations problem. If you try to make fractions out of any 2 of those letters, you could do r over y, y over r, x over y, y over x. What else? X over r over x. Did I get them all? That's it. There are 6 different ways of choosing 2 of the sides, okay? That's why there are 6 trig ratios. We're just defining which of the 2 sides, okay? Let's move on. Number 2 is the same question. They're giving you an xy point, and they want to find a couple of specific trig ratios. So first thing I would do is find that r value. Let me move that over. We know r equals square root of x squared plus y squared. So that's square root of -3 squared plus -4 squared. Square root of 9 plus 16 is the square root of 25. So r equals 5. Okay, great. So then sine theta, remember I told you to memorize, sine goes with y, right? It's the y number over the r number. So the y number is -4 and the r number is 5. That's sine theta. Sine theta equals -4/5. Secant theta, okay, what was the ratio for secant theta? R over x, r over x. So that's going to be 5 over -3. That's it. Now keep in mind, it doesn't matter where that negative is, all right? Typically, if you saw it written in a book, they'd probably put the negative with the fraction. It's a negative fraction value. It doesn't mean it's a -3. It's just a negative and a fraction. Okay? Answers are -4/5 and -5/3. Example 3 is the exact same question as examples 1 and 2, only it's not easy to recognize because they don't give you the xy point. Okay? Basically, what we need to do is figure out that xy point. Okay? They're giving me the terminal side of theta is defined by this equation. All right? They're giving me an equation. And we want to find an xy point. So one thing we could do is graph it, but another thing we could do is just make a table. Okay, so if I make a table and plug something in, you know, if I plugged in 0, I would get 0 plus 2y equals 0, 2y equals 0, so y equals 0. I can see the point 0, 0 is one of my points that's on this line, right? Okay, but the problem with that is if you look back at your formulas, remember how a lot of them we didn't want x and y equal to 0? We don't really want those zeros showing up, okay? So let's go back and think about this, okay? Let's just find another point. Find a non-zero point. So how about, what if we use x equals, really an even number would probably be best. 2 plus 2y equals 0. Subtract the 2, so 2y equals -2. Divide by 2, you get y equals -1. So we've got the point 2, comma, -1. All right. That point is on that line, and any point that's on that line is going to work. It doesn't really matter. Okay, 4, -2, 6, -3, any point that you can find on that line is going to work. Okay, so we're going to use that point. We've got an x number and we've got a y number. So let's find our r. R equals 2 squared plus -1 squared. That's going to be 4 plus 1 square root of 5. Okay. R equals the square root of 5, right? R equals the square root of 5. Okay. So, great. We want to find cosecant theta. Think about the ratio for cosecant theta. Cosecant theta is r over y. So we're looking at r is square root of 5, and the y number is -1. Okay, so reduce that, and you've got cosecant theta equals -square root of 5. we want cotangent theta. And the cotangent ratio is x over y. So look at x over y. You've got 2 over negative 1. That's going to reduce to negative 2. So we've got cotangent theta equals negative 2. There, you've got it. Okay, so again, the key here was coming up with that point. If you come up with that xy point, you can find your r value, and you'll have any of the 6 trig ratios that you want. Example 4, find the values of the 6 trig functions for an angle of 90 degrees, okay? It's really the same question again, okay? It's the same question, but we want that point. So think about an angle of 90 degrees. Can you think of an xy point that would be on that line, that vertical line there at 90 degrees? There's a lot of them. 0, 2, okay, that would work. 0, 1, 0, 2, 0, 3, 0, 57. There's an infinite number of possibilities here. You're just going to have to reduce. So, 0, 2, maybe 0, 1 would be even better because it's the smallest one that you could use. But that's a good point, okay? Because we've got an x and we've got a y, so we should be able to find that r. R equals the square root of x squared plus y squared. Square root of 0 plus 4, square root of 4. R is 2 in this example. Okay? If you used a different point, your R would be a different number. You're just going to have to reduce a little bit differently. Okay? So if we think about, it says find the values of the 6 trig functions. It wants all 6 of them. Okay? This problem wants all 6 of them. So fine. Let's start with sine theta. Don't forget your theta. Remember, sine goes with y. So y over r is 2 over 2, which is 1, right? And if I'm going to do cosine theta goes with x. X over r, that's 0 over 2, which is 0. Tangent theta, it's y over x. That's 2 over 0. That's undefined. Cotangent theta is x over y. 0 over 2 is 0. Cosecant theta is r over y. 2 over 2 is 1. And secant theta, the last one, secant theta is r over x. So we're doing 2 over 0. That's undefined as well. So we've got them all right there. If you want to wrap this up and write it in a more condensed way, sine theta equals 1. Cosine theta equals 0. Tangent theta was undefined. Cosecant theta was 1. Secant theta was undefined. And cotangent theta was 0. Find all 6 trig functions for an angle of 90. There you go. Find sine theta, cosine theta, and tangent theta for an angle theta in standard position with terminal side through this point. So again, it's the same thing. They've given me an x and a y. I'm going to need to find r. Square root of 9 plus 0. Square root of 9 is 3. So we've got r equals 3. So we've got x, we've got y, we've got r. We should be able to find any of the 3 trig functions that they asked about. Sine theta, we know sine goes with y. It's y over r. So in this case, that's going to be 0 over 3 is 0. We want cosine theta, and that's x over r, or negative 3 over 3 is negative 1. We want tangent theta. Tangent is y over x. So in this case, we look at our y number is 0 over x negative 3. That is 0. Okay. So imagine, if I drew this picture, does anybody know what angle I would be representing? Not 0. If I draw the point negative 3, 0, and think about that angle, that's 180. Okay, so if I went over onto a calculator and typed in sine 180, I should get 0. Cosine 180, anybody know? What do you think you're going to get? Negative 1. Tangent 180, it's going to be 0. Okay, that's what I've done. We didn't know the angle. We didn't think about the angle. We didn't need to know the angle, but that's what we've done. Okay, we got 0, negative 1, and 0. This chart just kind of summarizes some of the common angles. These angles right here, 0, 90, 180, 270, and 360. Think about where those come from. I know we've talked about this before. 0, 90, 180, 270, and 360. These are the angles that form the quadrants. 1, 2, 3, 4. So they're called the quadrantal angles. So if you notice, when you do sine, cosine, that kind of stuff, you're going to get zeros and ones and maybe undefines. So if I said something like cosine 180 degrees, how you'd use this chart is you'd go cosine 180 equals negative 1. That's how you'd use that. So what's tangent 270? Undefined, right? Reciprocal identities. So this is kind of how you're going to remember them. Cosecant theta is the reciprocal of sine theta. And secant theta is the reciprocal of cosine theta. And cotangent theta is the reciprocal of tangent theta. So just remember, those are the reciprocals. Cosecant and sine go together because they're reciprocals. Secant and cosine, cotangent and tangent. They are reciprocals of each other. Example 5a uses that concept of reciprocals. Probably the easiest question of the day. We want to find cosine theta, given that secant theta is 5/3. So knowing that cosine and secant are reciprocals, can anybody tell me what cosine theta would be? 3/5. That's it. Cosine and secant are reciprocals, so just flip it. That's it. Now 5b is a little bit harder because the numbers are harder, but to start with, since these are reciprocals, you should know that sine theta is going to equal negative 2 over square root of 12. That should be pretty obvious, okay? But we just have to do something with that square root of 12. So go back to algebra class. Square root of 12 is square root of 4 times square root of 3, or 2 times the square root of 3. So think about it that way. You can reduce square root of 12 just like you did a couple of years ago. So we can think about this as negative 2 over 2 square root of 3. 2's cancel. I've got negative 1 over square root of 3. We don't normally want to end up with the square root on the bottom, so don't forget your algebra trick. We can multiply by square root of 3 over square root of 3. And that's going to give me negative square root of 3 over 3. Hardest part about that is the algebra.